All right, so in this video, we are going to do some factoring. So let's start out with this example, right? Factor completely. Now, in this case, our expression is in the form of x squared plus bx plus c, right? Because in front of the x squared, we have a coefficient of 1, so just x squared and x squared. We have a value for b and a value for c. So whenever you have something in this form, what you want to do is you want to think of two numbers that multiply to this number, which is positive 90, and at the same time add to make this number negative 19. You have to find two numbers that satisfy that. Okay, and so to determine what pair of numbers satisfies both of these, what you can do is you can think of the factors of 90, right? Because in this case, we're thinking of numbers that multiply to make 90, so we're thinking of factors of 90. And we're trying to think of a pair of factors from 90 that add to make negative 19. So for instance, one pair is 1 and 90. 1 and 90 obviously don't add to make negative 19. In fact, we're going to have to make both of these numbers negative for them to still multiply to make a positive number, but at the same time to add to make a negative number. So we need a pair of numbers that are both negative. As you can see, when you add these, you get negative 91, not negative 19. So we'll have to keep going. So then what you do is you increase this by 1 each time. So negative 1, let's consider a negative 2. Well, the pair that matches with that would be negative 45, right? Because these two numbers multiply to make 90. But again, they don't add to make negative 19, so we have to keep going. Negative 3, negative 30, got to keep going. Now, negative 4 isn't a factor of 90 because if you do 90 divided by negative 4, right, it doesn't divide it evenly. So, in fact, I believe it's 22.5, right? It doesn't divide evenly, so it wouldn't be that. And then negative 5, well, 90 divided by 5 is negative 18. But when you add those, you don't get negative 19. Negative 6, well, negative 6 and negative 15 works, but again, that adds to negative 21, not negative 19. 7 doesn't work, 8 doesn't work, but 9 does. And when you add these two together, you do in fact get negative 19. So this was the pair we were looking for, right? Negative 9 and negative 10 satisfy both of these at the same time. And so that's actually the pair we were looking for. Negative 9 and negative 10, right? Negative 9 and negative 10. Those are the two magic numbers. And so now that we know these two numbers, here's what we do with them, right? Whenever we have something in the form of x squared plus bx plus c, the way it works is, right, you have two parentheses. You put x here and x here. But then all you got to do is put your magic numbers in each of them. So you have minus 9 and minus 10. And that's it. Now it's completely factored. And that's basically it for this problem. I'll just keep going. I like doing that. That was good, right? Okay. So next we'll just move on to the next problem, which is x squared plus 2x minus 24, right? Factor this one completely. Again, it's in the form of x squared plus bx plus c, right? X squared plus bx plus c, right? It's in this form because you can see x squared is just x squared, 2x is bx, and minus 24 is your c, right? So it is in that form. So it's going to be the same exact sort of problem that we did previously, right? Where we're trying to think of two numbers that multiply to make this number, negative 24, and at the same time add to make this number, positive 2. So in this case, we're thinking of factors of negative 24 that add to make positive 2. Now here's the thing, when you're considering factors of a negative number, one of the number, basically in each pair of factors of a negative number, such as negative 24, right, you might be thinking 1 and 24, but in order for these to be a pair of factors of negative 24, one of the numbers has to be negative, right? So we could either make the 1 negative, or we can make the 24 negative. But for this particular case, we need the pair of numbers to add to make a positive number, which means we want to make the smaller number negative in order to add to a positive number, right? But when you add these two, yes, you get a positive number, but you don't get 2, so we have to keep going. So after that, we test out -2. Well, the number that would work with this would be 12, right? -2 times 12 is -24. But again, they don't add to make 2, so we have to keep going. -3 and 8 doesn't work. -4 and 6, well, yes, this does result in 2. So this was the pair that we were looking for. -4 plus 6 equals 2. So that's exactly what we do. We just do -4 and 6, right? That would be the two numbers that satisfy this. And so just like before, the way it works is when we factor this, we get 2 parentheses, x here and x here. We take these two numbers and we just plug them in. So it's really -4 and +6. And now it's completely factored. And that's really what it's all about. So now we just keep going. Yeah, this video is mainly about practice. So we're just sort of regurgitating you, right? Regurgitating you on it, right? That was good. All right, again, this is in the form of x squared plus bx plus c. So we're thinking of two numbers that multiply to make this number positive 30, and at the same time add to make this number positive 13. Well, in this case, we're thinking of factors of 30, right? And we're considering factors of 30. The first pair could be 1 and 30, but these obviously don't add to make 13. So instead, if we think of 2, well, 2 would go with 15. But again, doesn't add to make 13. So then we consider 3 and 10. Well, turns out if you add those together, you do get 13. So this is actually the pair we were looking for, right? So 3 and 10. And so really, now that we found the pair that we were looking for, now we just go back to do what we did before, right? We make 2 parentheses. We have x here and x here. We have +3 and +10. We just put those in their places. And so this would be your answer. So that's really how you do it. For our next example, we have x squared minus 3x minus 70. Right, factor this one. So in this case, again, it's in the form of x squared plus bx plus c. So we're thinking of two numbers that multiply to make -70 in this case, and at the same time add to make -3. Okay, so in this case, we're thinking of factors of -70. Right? So factors of -70. Well, the first pair we would automatically consider is 1 and 70, right? Now remember, since these two numbers must multiply to make a negative number, one of these numbers has to be negative. Right? So we could either make this -1, or we could make it -70. But since we want to assure that these two numbers add to make a negative number, we will make the bigger number negative. That suffices that these two numbers will add to make a negative number. Right? This doesn't add to -3 though, so we have to keep going. So if we choose 2 in this case, -35 would correspond to that. Again, it doesn't add to -3, we got to keep going. 3 doesn't work, right? 70 is not divisible by 3. 4 doesn't work, right? 70 is not divisible by 4. If we choose 5, this will be -14. But again, doesn't add to -3. 6 doesn't work, but 7 does. And when you add these two together, you get -3. So this is the pair that you're looking for, 7 and -10. And so that's really what you get. And therefore, just like we've been doing, right, we get 2 parentheses, x here, 7 and -10. So we just get something like that, and that would be our answer. That's basically how that works. So now we just keep going. So let's step this up a notch. We have 4x squared plus 20x. I think it's minus 96. Factor completely. Now, in this case, it is not like the previous examples, right? In the previous examples, it was in the form of x squared plus bx plus c. But this is in the form of ax squared plus bx plus c, because we actually have a number in front of the x squared. Well, visually speaking, right? Originally, it was technically 1x squared, but But in this case, we actually see a number there. So that's what differs this case from the previous ones. And whenever you get a case like this, the first thing you want to check for is you want to see whether or not you can pull out a greatest common factor. It turns out for the case where you have x squared plus bx plus c, there is no greatest common factor, so we didn't even have to check that. But when it comes to ax squared plus bx plus c, you have to check to see if there's a greatest common factor out of each of these 3 numbers. So you need to determine the, I'll write it right here. You need to determine the greatest common factor of these 3 numbers. In this case, I'm going to consider the positive versions of those numbers, because that's really all we have to think about is the positive versions of those numbers and what the greatest common factor of them is. And one trick you can use to determining the greatest common factor is the fact that the greatest common factor cannot be any bigger than the smallest number in the set. In this case, 4 is the smallest number in the set. Therefore, the greatest common factor of these 3 numbers cannot be bigger than 4. The largest possible value for the greatest common factor is 4. So let's just check to see if 4 is the greatest common factor. Well, 20 is divisible by 4 and 96 is divisible by 4. So yes, 4 is the greatest common factor, right? Just so everyone knows how to do that. So then you can pull out a 4 from each of these 3 terms. What's going to be inside the parentheses? Well, you're going to do 4x squared divided by 4 and you get x squared. Then we have a plus sign. So positive 20x divided by 4 is positive 5x. Negative 96 divided by 4 is minus 24. And so that's really what we get. Right, so now we've pulled out a greatest common factor, but we have to see if we can go even further. Because notice, for this inside parentheses, now we have something that is in the form of x squared plus bx plus c. We want to see if we can factor this. So it's basically it's sort of a 2-step problem. So now, if you recall, to determine, to factor this, we think of 2 numbers that multiply to make negative 24 and at the same time add to make 5. Or positive 5, right? And we're thinking of factors of negative 24. Okay, the first obvious pair is 1 and 24, and really, it needs to multiply to a negative number. Therefore, we need to make sure that one of these is negative. One of them has a positive sign, the other has a minus sign. Well, we could either make this negative 1 and 24, or we can make it 1 and negative 24. Which one do you want to make it? Well, since we need these two numbers to add to make a positive number, we will make the smaller number negative. That assures us that when we add these two numbers together, we get a positive number. Unfortunately, these two numbers don't add to make 5, so we have to keep going. So we have -2 and 12. Again, that doesn't add to make 5. So we keep going. -3 and 8. Well, yes, if you add these together, you get 5. So this is the pair that we were looking for. And so that's it. -3 and 8. And so that's it. That's basically the numbers we're going to use to factor what we have here. So we have 4 times, and again, we're going to split this up into 2 parentheses, x here and x here. Right, we know it's -3 and 8, so we have -3 and +8. And we cannot go any further with this, right? That's as far as we can go with that. So this is basically it for factoring this one. So now we are continuing going. I like that one, continuing going. Let's go, I love saying that. So that's that one. So now we move on to the next one. That was a good way to transition, right? Okay. So we have 4x squared minus 8x minus 252. So, first things first is to realize that this is, in fact, in the form of ax squared plus bx plus c. And because it is in that form, we first need to check to see if there is a greatest common factor between these 3 terms. And, well, that means that we're trying to determine the greatest common factor, in this case, of our 3 numbers. In this case, the positive versions of those numbers is what we're really thinking about, 4, 8, and 252. And it's also pretty convenient to use the trick that we used last time, right? The greatest common factor of any set of numbers is not bigger than the smallest number in the set. So in other words, the greatest common factor of these 3 numbers cannot be any bigger than 4. 4 is the largest possible value for the greatest common factor of these 3 numbers. So if we check to see if 4 is the greatest common factor, well, 8 is divisible by 4, but is 252 divisible by 4? Pretty good question. There's a few tricks that you can use. One of them is you can actually use your calculator, right? That one was a good one, right? I had to do that. But anyways, without a calculator, let's say you're out in the wild and you don't have a calculator on you, right? I like that. That one was good. All right, that was bad, actually. How do you know if this is divisible by 4? Well, check this out. Any multiple of 200 is divisible by 4. So we can split this up into 200 plus 52 over 4. And we can write this as 200 over 4 plus 52 over 4. We know that this will be divisible by 4, so we don't care about this. All we care about is if 52 is divisible by 4. Which it is, because if you recall, 48 is divisible by 4, therefore 52 is divisible by 4, right? And so, yes, 252 is in fact divisible by 4. So, yes, greatest common factor is 4. So we will factor out a 4 from this trinomial. 4x squared over 4 is x squared. Minus 8x divided by 4 is minus 2x. Minus 252 divided by 4 is minus what? Well, let's determine that. Let's do exactly what we were doing last time. Right? You can split this up into 200 plus 52 over 4. We could split this up into 200 over 4 plus 52 over 4. 200 over 4, in your head, that one's pretty easy, right? It's just 50. 52 over 4, if you don't know this one right away, you can split this up into 48 plus 4 over 4, which is really 48 over 4 plus 4 over 4, which at this point, I think you can pretty much see what the answer is going to be. It's going to be 63. Therefore, this becomes a 63. And so now that we have done that, now we have something in the form of x squared plus bx plus c. So we have to see if we can factor that now. And just like we've been doing, right, just eventually becomes automatic the more you do it, right? You're thinking of two numbers that multiply to make negative 63, and at the same time add to make negative 2. So, in this case, numbers that multiply to make negative 63 implies that we're thinking of factors of 63. Most obvious one being 1 and 63. However, because we're multiplying two numbers to make a negative number, one of these numbers has to be negative. We could either make the 1 negative or the 63 negative. But because we're adding to make a negative number, we're going to want to make the bigger number negative. Because when you add something like this, you get a negative result. But of course, this doesn't add to make negative 2, so we have to keep going. 2 doesn't work. 3, on the other hand, does work, and this would be 3 and negative 21. Right? Now, we've done this a lot, right? It's like, maybe we don't need to keep listing factors, but we can think of one right off the top of our head. One common factor pair for 63 is 7 and 9. And you can see right away, right, these two pairs would add to make negative 2. And so eventually, the more you do this factoring business, you're going to start seeing what the result is right away. And so you're going to see 7 plus negative 9 is negative 2. Therefore, those are the numbers that we were looking for that satisfy this. So 7 and negative 9 is exactly what we were looking for. So now that we have that, we can now factor this to saying we're going to have x here and x here. We have 7 and negative 9, so that would be it. So plus 7 minus 9. And that's it. Now we have completely factored this. Next, for our next example, we have 6x squared plus 42x minus 48. Factor completely. Now, to factor this one, again, it's in the form of ax squared plus bx plus c. So at this point, we probably know that we're going to be looking for whether or not there exists a greatest common factor between these three numbers. So really, we're trying to determine the greatest common factor of 6, 42, and 48. Now, just like the trick we've been using, right? The largest possible value for the greatest common factor is the smallest number in the set. Well, we can see that each of the numbers in the set are multiples of the smallest number. Right? 42 is divisible by 6, 48 is divisible by 6. Therefore, the greatest common factor is 6. Right? Therefore, we factor out a 6. Factoring out a 6, 6x squared divided by 6 is x squared. 42x divided by 6 is 7x. Negative 48 divided by 6 is minus 8. So now we have something in the form of x squared plus bx plus c. So now we just use the trick that we've been using last time. We're thinking of two numbers that multiply to make negative 8, and at the same time add to make positive 7. Well, we're thinking of factors of negative 8, 1 and 8. Turns out we're actually right at the answer. We just got to make that one negative, so they multiply to make a negative number. But when you add these together, you do in fact get 7. So this is pretty nice. We have arrived at the magical numbers in one step. So negative 1 and 8 are the numbers we are looking for. So now that we have this, right, we do what we've been doing. X here, negative 1 and positive 8. So minus 1 plus 8. So this would be our answer. All right, next question. We have 4x squared plus 12x minus 40. See, is that the correct one? Yes, it looks like it. Factor completely. So really, to factor this thing, again, it's in the form of ax squared plus bx plus c. So let's see, is there a greatest common factor between each of these three numbers? Right, in other words, is there a greatest common factor between 4, 12, and 40? Well, notice, each of these numbers are multiples of the smaller number 4. Therefore, 4 is in fact the greatest common factor. Therefore, we can pull out a 4. 4x squared divided by 4 is x squared. Plus 12x divided by 4 is plus 3x. Minus 40 divided by 4 is minus 10. So now that we're at this point, we have something in the form of x squared plus bx plus c. And so what that means is we want to check to see if we can factor it. We're trying to think of two numbers that multiply to make negative 10, and at the same time add to make positive 3. So in this case, we have negative 10. We're thinking of factors of negative 10, the first pair being 1 and 10. Well, since we're multiplying to make a negative number, we need one of these numbers to be negative. But since we're adding to make a positive number, we'll make the smaller number negative. That assures us when we add these two numbers, we get a positive result. Okay, negative 1 plus 10 doesn't equal 3. So if we consider negative 2 and 5, this does add to 3. So this is the pair that we were looking for, negative 2 and 5. Therefore, we choose negative 2 and 5 to be the numbers we were looking for in the first place. Therefore, this becomes, right, we have x and x, we have minus 2 and plus 5. And so this would be your final answer. For our next example, we have 6x squared minus 45x plus 21. Again, this is in the form of ax squared plus bx plus c, so we have to see whether or not there's a greatest common factor between each of our three numbers. In this case, 6, 45, and 21. Using the trick we've been using, right, the largest possible value for the greatest common factor is 6, right? That's the largest possible value. But notice, 45 is not divisible by 6, 21 is not divisible by 6. If the smallest number in the set is not the greatest common factor, then consider the factors of the smaller number. In this case, if you think of all the factors of 6, I'm going to express it in a different way than we've been expressing it. These are all of the factors of 6 in order, right? 1, 2, 3, and 6. If 6 is not the greatest common factor of these three numbers, then check to see if the number before it is. In this case, 3. Is 3 the greatest common factor of these three numbers? Well, because 3 is a factor of 6, 6 is obviously divisible by 3. But we also know that 45 is divisible by 3 and 21 is divisible by 3. So 6 didn't work, but 3 did. Therefore, 3 is the greatest common factor. Right, that's another trick you can use. So now that we know that 3 is the greatest common factor, that's the number we're pulling out of this. Six x squared divided by 3 is 2x squared. minus 45x divided by 3 is minus 15x, plus 21 divided by 3 is 7. So what we're left with is we are left with 2x squared minus 15x plus 7 in parentheses. In all of the previous problems where we started with something in the form of ax squared plus bx plus c, we ended up getting something that was in the form of x squared plus bx plus c in our parentheses. This is the first instance where we still have something in the form of ax squared plus bx plus c in our parentheses. So what do we do if we can't pull out a greatest common factor from something in the form of ax squared plus bx plus c? Is it possible to go any further with this? Well, actually, yes it can. Yes, it is possible. That's what I meant to say. I messed that up. I messed it up. I'll take my bad on that one, right? Okay. But it's different from when you're doing the form x squared plus bx plus c, right? It's different in this case. Instead of thinking of two numbers that multiply to make 7, we're thinking of two numbers that multiply to make 2 times 7, or in other words, 14. But it's still at the same time add to make this number negative 15. Right? That's the only difference at this point. So really, we're still finding these two magic numbers. And so to find those two magic numbers, we're still considering the factors of 14. In this case, our first pair would be 1 and 14. And we would ask ourselves, do these two numbers add to make negative 15? But clearly they don't, because these two numbers are both positive. So it turns out we're going to have to make them negative in order for this to work, right? Because, a negative times a negative is still a positive, but we need to make both of these numbers negative so that they add to make a negative. It turns out that this works if we do that, because when you add these two numbers, you get negative 15, which is exactly what we were looking for. Negative 1 and negative 14 is the pair of numbers that satisfies both of these. So, now we go back to our trinomial. Turns out it's going to be slightly different than what we've done before, right? Instead of writing x and x, because the coefficient is 2x, instead write 2x and 2x. And right here we have minus 1 and minus 14. But we aren't done yet, because it turns out there's an additional step you have to make. You have to divide both of these parentheses by their greatest common factors. So in this case, you've got to think of the greatest common factor of 2 and 1, and you have to think of the greatest common factor of 2 and 14. Well, the greatest common factor of 2 and 1 is 1. The greatest common factor of 2 and 14 is 2. So you just have to divide each of these parentheses by those corresponding numbers, right? Of course, the 2x minus 1 doesn't change, but the 2x minus 14 becomes, well, in this case, 2x over 2 is just x, minus 14 divided by 2 is minus 7. And so that's the result. So as you can see, it's slightly different, but it's not much different. It's just, it just has a little bit of a tweak in how you do it. That's really all it is. So hopefully you'll be comfortable looking at some more examples of instances like that, because that's pretty much where we're headed at this point in the video. So let's make it a little bit more challenging. Let's say we have 15x squared plus 57x minus 90. How would you factor this one? Well, in this case, since it's in the form of ax squared plus bx plus c, we want to determine, is there a greatest common factor that we can pull out immediately? So in other words, we're trying to consider what is the greatest common factor of 15, 57, and 90. Well, again, the largest possible value for the greatest common factor is 15. But 57 is clearly not divisible by 15. So 15 can't be the greatest common factor. So if the greatest common factor of these three numbers is not 15, then consider the factors of 15. Right? We have 1, 3, 5, and 15, right? There's not that many, so it's going to be pretty convenient to use this option to our advantage. So even though 15 is off the table, we have 5, right? The number before 15 in this case is 5. We could see whether or not these three numbers are divisible by 5. Well, yes, of course, 15 is divisible by 5, obviously, right? We're listing factors of 15. But 57 is not divisible by 5. So 5 is off the table as well. So next we check 3. Is 15 divisible by 3? Of course it is. Is 57 divisible by 3? Well, that's a good question. Is 57 divisible by 3? Now there's this trick to determining divisibility by 3, and that's if you were to add the digits together. In other words, if you add the digits of 57, 5 and 7, you get 12. But since 12 is divisible by 3, therefore 57 is also divisible by 3. So yes, 57 is divisible by 3. 90 is also divisible by 3. Therefore, 3 is the greatest common factor of these three numbers. And so now we have determined that. As you can see, that's basically how you could do that. So now we know that 3 is the greatest common factor. We can pull out a 3 from this. So notice we have 15x squared divided by 3 is 5x squared. But what about 57x divided by 3? Maybe you don't know this one off the top of your head because that one's a little bit different from the others. Well, check this out. I can rewrite this 57 as 30 plus 27, which are easier to divide by 3 than 57 itself. Well, we know that this is just 30 over 3 plus 27 over 3. Right, this is 10, this is 9, the answer is 19. So you just get 19. In other words, 19x. Negative 90 divided by 3 is minus 30. And so that's what we get. So now that we're at this point, right, we've pulled out the greatest common factor, which means we can't factor the parentheses any further, right? So we're left with something in the form of ax squared plus bx plus c, which doesn't have a greatest common factor. Or in other words, the greatest common factor is just 1, so there's nothing to pull out. So now we have to resort the method that we used in the previous problem, which is, well, we're thinking of two numbers that multiply to make negative 30 times 5, which is negative 150, and at the same time add to make 19. So there's a little bit more going on with this one than the previous ones, right? Larger numbers. Right, so it's a good thing we've practiced smaller problems to work our way up to this larger problem. So in this case, we're considering the factors of negative 150. And 1 and 150 would be our first consideration. Now, really, since we're multiplying two numbers to make a negative number, one of these numbers has to be negative. But we'll make the smaller number negative, so that assures us that when we add these together, we get a positive result. It's not 19, so we have to keep going. Now, instead of considering 2, because I'm pretty confident by inspection, negative 2 and whatever the other pair is won't work. So let's just skip to negative 3 and see if that works. Well, when you add these together, that's 47, not equal to 19, so we just keep going. So let's just keep going, but I'm not even going to think about 4. I'm going to think about 5 because I know that one right away, right? 150 divided by 5 is 30, but again, negative 5 plus 30 is 25. But what you should be seeing is we're getting closer to 19, so we know we're pretty close by. So next, let's see if 6 works. Is 150 divisible by 6? Yes, it is. And you might not know what 150 divided by 6 is off the top of your head, but to determine that, I'll do that off to the side here. We know that 150 can be broken up into 30s. In other words, 5 30s, right? But really, just like that, right? 30 divided by 6 is 5, so really you get 5 times 5, which is 25. So the pair that would go with this is 25, and sure enough, when you add those together, you get 19. So that's the pair we're looking for, is 6 and 25, or negative 6 and 25, I should say. And so that is our pair. So now we're able to go back to what we had right here, and we can re-express this into 2 parentheses. But since it's not x this time, right? We have 5x. So what we're going to do is we're going to put 5x and 5x here, right? We have a minus 6 and plus 25. So we have minus 6 and plus 25. And now what we have to do is we have to divide both of these by their greatest common factors, right? You can't forget that step. So the greatest common factor of 5 and 6 is 1. The greatest common factor of 5 and 25 is 5. So doing that division, 5x minus 6 remains the same. 5x divided by 5 is x. 25 divided by 5 is 5. And that would be our answer. That's really the way it works. That would be our answer to this.